Record anyway. Okay, let's get started. So, like I said, we're gonna do this probably pretty fast too. Unit 3 is pretty easy, but it leads into Unit 4, and you have to know the things in Unit 3 to do Unit 4. Okay, to find the relative age of a dog, some people use the rule of thumb that every year in a dog's life is equal to 7 years of a human's life. You guys have heard that before?
Yes.
Okay, so what would an equation look like for that? So to represent dog years, what would I write here? 7 what?
7, D equals 7.
D equals, no, dog years equals 7 all the time?
Yeah.
Why H? So what am I doing in between those? I'm multiplying. So I'm taking the human year and multiplying it by 7, and I will get my dog's year. So now, who's got a dog? Okay, so I want you to write down how old your dog would be.
I have 2.
Write them both down. What? No. Okay. Algebra. I'm not going to wait every time. So, Bella, which many of you know when you walk by, is my yellow lab. She's 5 years old. This is how long I've had her. I had her since a puppy. And if I multiply her by 7 years, technically Bella is 35. How old's your dog? How old's your dog? 14. Yeah, so I bet he's moving a little slow too. Yep. All right. So what we're going to do down here is we're going to fill in this chart. These are the human age years. I want to know the dog age. And then this one I have the dog age. How old is it in human years? So we're going to fill this out independently. All right, so what would this one be? 7 and then?
28.
Then?
42. 7.
Okay. You just had an entire conversation by yourself about YouTube with not even participating with us. Don't let it happen again. Okay. All right, so the whole point of this is we're going to be looking at an equation, you're going to be looking at a graph, and you're going to be looking at a table. And you're going to have to determine if that is or is not a function. This is going to lead into 3.2, which is your evaluating functions by substituting. Okay? So what we're going to do is we're going to take this and we're going to graph it. I hate to break it to you guys, but some of you aren't really great at graphing. Okay, so this is your x-axis. Oops, you can't even see that. This is your x, and this one is your y. Okay, this is your x, this is your y. I remember this one's a y for the simple fact that I could make a y and finish out the tail of my y. So that's how I remember it's y. So what we're going to do is we're going to take these points, but before we can graph these points, we have to get a scale. What should our scale be for our x's? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10?
Yeah.
Can we do that? what should the label of the x-axis be?
Human years.
Yep, age in human years. Okay, is it going to be feasible on the y-axis to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way up to 70? No, I don't have that many lines. What are some suggestions?
7.
Y by 7.
Because that's what it is.
Exactly, it makes the most sense, right? Your intervals can be whatever you want them to be, but it has to stick. So if I go by 5s, I have to stay going by 5s. If I go by 10s, I have to stay going by 10s. If I go by 7s, I have to stay going by 7s. And what should the label be for my y-axis? Age in dog years. Okay. So now we're just going to plot our points. In 1 human year, it'd be 7. Do I go to 2? No, I skip over to, because I'm just graphing this table. I'm just graphing the table. So I'm going to go over to 4, and I go up to 28. 6 to 42. 9 to 63. And 10 to 70. The relationship, good call. The relationship between human years and dog years is a function. A function has input, and in this case it's human years. So this is our input. And outputs, in this case dog years. Functions have exactly one output value for each input value. So let me explain what that means. Because it kind of sounds funny, right? You're like, wait, what did she just say? For every input, so for every x, for every input, there can only be one output to make it a function. So let's hypothetically say, we'll get there. So for every input, there can only be one output. Okay? So if I'm saying that 4 years, the dog's 28, it can't be anything else but 28. I can't say, well, 4 years, he's 30. So a function means for every input, you only have one output. Okay? All right, let's flip it over. Tamara was worried about her 6-year-old dog, Suze. So she took her to 3 different veterinarians. Each vet told her the approximate age of her dog in dog years based on Suze's health. Tamara graphed her dog's age in dog years and included the 3 vets' approximations at age 6. Do you think this graph is a function? Because what did I just say? One output. So why are you saying this would not? Which one? 6. I can't say that the dog is 42, whatever, like, I can't even read that one. 49. 56. 56 and 80. I can't say that dog has 3 ages, can I? No. That does not make any sense. Right here is why this is not a function. We're going to say, no, this is not a function. And I'm going to teach you the trick, especially if you have a graph. Take a pencil. Put it on the y-axis. If I slide my pencil over here, am I only hitting one point vertically? Yes? Am I still only hitting 1 point vertically? Am I still only hitting 1 point vertically? Am I still only hitting 1 point vertically? No. This is called the vertical line test. If the graph passes the vertical line test, it's a function. If it does not pass the vertical line test, it's not a function. So I'm doing this vertical line test, boom, I'm hitting more than one dot, not a function. In my reasoning right here, do you think this graph is a function? Why or why not? Well, there are three ages for 6, right? That's what we're saying, that there are 3 different ages for 6. And we know that a function can only have how many outputs? 1. Okay, so I want you to sketch me any graph, just a sketch of one that would not be a function. I want to see what you come up with. Sketch a graph that would not be a function. Once you sketch your graph, test it with the vertical line test. Does it pass it? Does it not? Are there an infinite amount of graphs that we could draw? Yeah. What do you think of a graph? What happens if I do this? Function, not a function. Because the whole way I'm hitting 2, right? Okay. Function, not a function. Function. You're going to see some where there's a U like this, not a function, right? And then they take that same U, they twist it, and they go like this. This is a function. So be careful. The ultimate goal is, does it pass the vertical line test? Do these 2 pass the vertical line test? No. Do these 2? Yes. Yes, sir. Yeah. What? This upside down one? Yeah. Because if I'm going along, I'm only hitting 1 point the whole way.
Oh, so it's not like a straight view, it's like spread out.
Yeah, like this, kind of. Yeah. Yep. All right, let's switch over to that presentation that I just gave you. I think I'm out, Max. Just go quick. And thank you for reminding me to print more so the sub doesn't have to deal with that tomorrow. Okay, here we go. So today's content objective. I can determine if a given set of data is a function. Pretty simple, right? We've already looked on how we do it with a graph, right? Okay. So let's look at our vocabulary. Function, a relationship between two variables that has one output value for each input. So we said every input has only one output. That's saying the same thing they did, I think just in easier words, in my opinion. You're going to see the words domain and range. Domain is your input value. So is that your X or your Y? Your X. So this is your X values. And it's going to have range, the set of output values. So what's the output? Y values. Very good. Oh, and this last one we've already talked about, the vertical line test. A test used to determine if a graph represents a function by checking to see if the vertical line passes through no more than one point of the graph of relation. So just like we did, just taking it along. If it hits 2 points, automatically not a function. Questions on our vocabulary? Okay. All right, let's flip it over. Okay, so what we're going to do, give the domain and ranges of each relationship. Determine whether or not each relationship is a function. So first, we're just going to list all the domains. The domains are what? X or okay. So 2, 4, 6, 8. And then right below that, we're going to list the Y values, our outputs, the ranges. 4, 6, 8, 10.